Welcome. This is for IGCSE Physics Paper 4, Practice Paper 1. So, first question, define pressure. What is pressure? The pressure is force applied per unit area. So, we are going to write force applied per unit area is going to be called as pressure. Then, describe how pressure in a liquid varies with its depth and with its density. So we know the formula for delta P, pressure equals to density times acceleration due to gravity times height. So we can see that if the height increases, the pressure also increases. So what I can write it out, when the depth increases, when depth increases, when depth increases, pressure also increases. Same is the case with the density. So rho is the density. If the density increases, pressure also increases. So what I can write as density increases, pressure also increases. State two energy resources for which the sun is not the main source. So what are the two energy resources for which the sun is not the main source? We can write it as geothermal, and we can write it as nuclear, or we can even write it as tidal. State and explain whether each of the following methods of electrical power generation is renewable. Power generation in a nuclear power station. So nuclear power station is non-renewable. Why it is non-renewable? Because it has to be completed at any one or the other day. It gets exhausted. So what you can write it as all nuclear fuel can be used up. Another power generation from waves in the sea, it is renewable because the waves in the sea will be never be ending. Why the waves in the sea will be never be ending? Because it is all because of the air. So it is renewable because always produced by wind. Question number 2. This figure 1 shows the balloon filled with helium gas. It is filled with which gas? Helium gas. The mass of the balloon is 120 kgs. Calculate the weight of the balloon. Show your working. So for calculating the weight, what are we going to do it out? It is going to be force acting on object. Acting on object due to gravitational force or gravitational acceleration. Gravitation and acceleration. So force W equals to nothing but what? Mg. So what is the mass? 120 kgs. And G, what is the value of G? It is given in the instructions at the beginning of the question paper. We should be taking 9.8 meter per second square. So I take that one as times 9.8 meter per second square. It's going to become as 1176, but round it out to three significant figures, 1200 newtons. Don't forget to write the units. The resultant force on the balloon is 54 newtons. Show that the acceleration. So just now we have learned that force is equals to mass times acceleration. Mass times acceleration. So what was the force? It is 54 newtons. So 54 newtons equals to mass 120 kgs times acceleration A. So A equals to 54 divided by 120, which is going to be 0.45 meter per second square. That's what he's asking us to prove it out. That's question number 2. Part B. Coming to part C, the balloon accelerates upwards from rest 0.45 meter per second square and 8 seconds. So what we are going to do, we are going to list it out all the data that will be making our life easier. So it is starting from rest. Initial velocity is 0 meters per second. Acceleration is 0.45 meter per second square. Time equals to nothing but what? 8.0 seconds. And final velocity is being asked. So we have a formula: acceleration equals to v minus u upon t. 0.45 equals to v minus 0 by 8. This gives me v equals to 3.6 meters per second. So write down that answer: 3.6 meters per second. Calculate the distance traveled by the balloon in the first 6 seconds, 8 seconds. So we know that speed equals to distance by time. But I am not going to use this formula. Why am I not going to use this formula? Because we know that balloon was starting from rest over here, 0 meters per second. It was going up, accelerating, and it reached over here with a velocity of 3.6 meters per second. Now that we can see that speed is not constant. Speed is not constant. So therefore, what is the thing is, we are going to use it at average speed. We will be using average speed. So in that case, the formula is going to be distance equals to average speed times time. The average speed is 1.8 meters per second times, how do I get the average speed? Average speed was 1.8 meters per second. Then times time. Time is going to be 8 seconds. Seconds gets cancelled. Then the answer is going to be 14.4 meters. So I'll be writing it out over here, 14 meters. So I use the average speed and then I will be getting it out. But before that, we should be knowing it out the average speed. How do I know the average speed? Average speed equals to the initial speed plus final speed divided by 2, which is going to be 1.8 meters per second. That's the answer. Now coming to question number 3. This figure is simplified diagram of a digital circuit. The output of a logic gate is Y, controls the buzzer. The input A is logic gate X and input B over here we have logic gate Y. Now we can clearly see that this is a NOT gate and this is a NOR gate. So the first one is a NOT gate and the second one is nothing but what? NOR gate. Now where is input A? Input A is going to the NOT gate. What is the meaning of NOT gate? We will be getting always the opposite. So the X value, this is the X value. Output of X will be always opposite of the input A. If it is 0, it's going to be 1. 0 means 1 and 1 means 0. 1 means 0. So I am getting it an input from here for Y and like from over here input B. And B is a at B where we have a NOR gate. So what am I going to use it out? I am going to use it out this as the input and this as the input for Y. These two will be going for Y. But Y is an OR gate, NOR gate. What is NOR gate? NOR gate is nothing but what? Opposite of OR gate. Opposite of OR gate. So first of all, for opposite, 0 plus 1. 0 plus 1 is going to be 1. 1 plus 1 is 1. 0 plus 0 is 0 and 1 plus 0 is nothing but what? 1. But now it is an OR NOR gate, so opposite of this one. So what is it going to be the opposite of this one? 1 is 0, 0, 1, 0. This is going to be the answer. Now input A is the output of the humidity sensor which gives logic 1 when the humidity is high. When the humidity is high, it gives. So 1. So these two are high. And logic 0 when humidity is low. These two are low. Input B is the output of a light sensor which gives logic 1 in case of a bright. So bright. So this is bright and this is bright. And 0 when it is dark. So this is dark and this is dark. The buzzer sounds when the output of Y is 1. So when it is sounding, when the output is 1. So in this case, it is sounding. We can see that it is sounding in this case. So what it should be? It should be input A should be higher So A is 1 and B is 0. Means what is that? When humidity is high. Humidity is high and there is darkness. Next, the output of a digital circuit alone is not able to operate the buzzer. Ring the component from the list that must be connected between the output of the digital circuit and the buzzer. So first of all, we should know the uses of all these things. So fuse. What is it a fuse will be doing? It will be using for the breaking the circuit. Breaking circuit. Whereas heater. Whereas what is the use of heater? The heater will be converting electrical energy to thermal energy. Then relay. Relay will convert low current to high current. So over here, when the buzzer, the digital output is not sufficient for the buzzer, so we have to convert into high current. So therefore, relay is going to be the best one. Relay, because as it converts low current to high current. Whereas resistor is wrong. Why does the resistor will be using it out? It will be reducing the current. So it is wrong. What is thermistor? Thermistor is also wrong because it measures temperature. So therefore, other all things are wrong. So answer is going to be relay. Next is question number 4. The figure 4.1 is an incomplete ray diagram showing an object O, a converging lens and the principal axis. The focal points of the lens are each labeled at F. Complete the ray diagram. So when I try to draw the ray diagram, extend over here, we see that they are not intersecting. So we get it backwards. I produce it backwards and I can see that they are intersecting over here. So let me do neatly over here. So it can be clearly seen that an image is formed over here. An image is formed over here. Now completed the ray diagram. Correct these three descriptions in the list which describe this one. So we can see that it is clearly enlarged and it is upright and it is virtual because it is not formed on the opposite side. It is formed on the same side. It's virtual. State the name of the defect of the vision that can be corrected by a converging lens. So which defect by converted? Long-sightedness. The people who are having long-sighted will be using converging lens. Describe how a converging lens corrects this defect. So basically what happens is in the people who are suffering from long-sightedness, this is a structure of an eye, and the image is formed behind the retina. The image, I take the image of an object is formed behind the retina. So that is the reason the people of long-sightedness will be suffering with the behind the retina is formed. Whereas this is retina. So when I introduce a converging lens, that is a concave lens, when I introduce a converging lens over here, then the focal point is decreased. The focal point is decreased, or focal length is decreased, and now the image will be formed on the retina. See that the image will be formed on the retina. So it reduces the focal length. So what can I write it out over here as a reason? So converging lens reduces focal length of the eye so that rays can converge on retina. Question number 5. On a journey, shows a speed time graph of a person on a journey. On the journey, he walks and waits for the bus. He then travels to the bus, he gets off the bus and waits for 2 minutes. He then walks again and his journey takes totally 74 minutes. For the whole journey, find the distance traveled. Distance is going to be nothing but what? Area. But finding it out area of the rectangles, remember this is in minutes and this is in hours. So convert this also into hours. How do I convert into hours? By dividing by 60. So, so the length is going to be 5. 5 times the distance is 20 divided by 60. Plus the next time the length is 40. And again the distance is 20. 20 divided by 60. Plus next time it is 22. Then the distance is nothing but what? 6. The height is going to be 6 times and the distance is 22 divided by 60. Simplify all this, you should be getting 17 kilometers. What is the average speed? Average speed equals to total distance by total time. Total distance divided by total time. What was the total distance? Just now we got 17 kilometers and total time was 74 minutes divided by 60, which is 14 kilometers per hour. Next, state and explain which features of speed time graph shows the acceleration. Basically, speed time graph, the gradient. Gradient shows the acceleration. Gradient shows the acceleration because what is the thing is gradient gives you change in speed by change in time. Speed by change in time. Next, state and explain the acceleration of the person at a time of 40 minutes. Where was 40 minutes? When we go over here, the 40 minutes over here, when I see it is a straight line. Straight line means the gradient is 0. Gradient is 0. At 40 minutes, the gradient is 0. Gradient is 0 means acceleration is equals to 0. Coming to question number 6. State and explain two features of liquid and glass thermometer that are necessary for linearity. So, basically the diameter. The first thing, there are many things, but I'm choosing this one. So, diameter of capillary. Diameter of capillary should be uniform. Why it should be uniform? The reason, for what reason it should be uniform? So that the volume increases uniformly. Volume increases uniformly. Another one what we can take it out is expansion of the liquid should be uniform again. We are using mercury, basically expansion of liquid should be uniform. Why? What is the necessity for that one? So that this will ensure, what it will ensure? It will ensure expansion per degree as constant. The value of the heat capacity of the hot junction of a thermocouple thermometer is important in ensuring that it can measure the temperature changes very rapidly. Why? Because the heat capacity at the hot junction of the thermocouple should be very small. Why it should be very small? So that the thermometer will reach the surrounding temperature rapidly. So what I can write it out? The heat capacity of hot junction of thermocouple is very small. Why it should be very small? So that thermometer will reach the surrounding temperature faster. Then the hot junction of a thermocouple thermometer has a heat capacity of 0.11 joules per degree centigrade. Calculate the thermal energy. So formula is E equals to mc delta T. The temperatures are given in degrees Celsius. So we need to convert into Kelvin. 20 plus 273, 293 Kelvin. 345 plus 273, which is 618 Kelvin. So now the heat capacity has been given as 0.11 times delta T is nothing but what, 618 minus 293, which is going to be 35.75. So write it as 36. And this is energy. So don't forget to write the units as joules. Now coming to question number 7. Show that 1 light year equals to this much. What is the meaning of light year? What is this? It is the distance traveled by light in 1 year. So distance equals to nothing but what? Speed times time. What is the speed of the light? Speed of the light is 3 times 10 to the power of 8 meters per second. Time in 1 year. 1 year will be having 365 days. But 1 day will be having 24 hours. 1 hour will be having 60 minutes. And 1 minute will be having 60 seconds, because you should be calculating into seconds. So when you simplify all this, you should be getting it out 315,360,000. So which is going to be 3.51 times 3 times 10 to the power of 8, which is going to become nothing but what, 9.5 times 10 to the power of 15 meters. State one measurement that is taken when determining the speed of v at which the galaxy is moving away from the Earth. So whenever it is moving away from the Earth, we call it as redshift. Redshift, because the wavelength will be keeping on increasing. Wavelength increases because the wavelength of electromagnetic radiation emitted from the receding stars and galaxies will be keeping on increasing. So therefore, what is that one? Change in wavelength. What is the one measurement? What will we do? We find it out, change in wavelength. Write down an equation for v and the distance. This is just the Hubble's constant. Vh equals to v upon d. State how the distance of the far galaxy can be determined other than by using the equation 1. So we can tell that is by the brightness of a supernova. Now coming to the next question. This is a very straightforward question. Question number 8. A radioactive nucleus of carbon decays to a nucleus of nitrogen by emitting a particle. Complete the nuclear equation and state the name of the particle. So 14, 14. So this has to be 0, 6, 1. This has to be -1. So what is 0 and -1? Beta particle. A radiation detector in a laboratory records a reading of 10 counts per minute. There are no radioactive samples in the laboratory, so means there is no background radiation. Explain why the radiation detector records a reading and suggest a possible source. So that's what they should be having some background radiation. That background radiation can be from either from the ground, it can be from the ground, or it can be from the buildings, or it can be from the food, or it can be from the air, and or even it can be from the sun. So these are all the from where we are getting it out, the background radiation. Now carbon 14 has a half-life of 5700 years. There are atoms of carbon 14 in all the living organisms. An archaeologist digs up some ancient wood in same laboratory as B1. A sample of ancient wood gives a reading of 20 counts per minute. 20 counts per minute. An equivalent sample of living wood gives an 80 counts per minute. But we know that what it says, there was a 10 counts per minute background radiation. So we need to subtract it out. If you subtract, so the examiner knows that we are knowing that concept of background radiation. So we should be subtracting and writing it out over there. Now, it is suggested the age of the ancient sample is 11,400 years. So basically we know that the half-life is 5,700 times 2 will become 11,400 years. Means there are two half-lives. So for example, whenever I'm starting at 70, if at all I'm starting at 70, one half-life gives me 35, another half-life gives me 17.5. But how much do is left over? The leftover is nothing but what? 10. So it is more than 10. So therefore there would have been another half-life 3, but this will become 8.5. 725. But again, what will happen? It is less than 10. So therefore, what it can be saying that we can say that it is more than two half-lives, but less than three half-lives. The age can be more than two half-lives and less than three half-lives. So that's going to be the answer. Now coming to question number 9. State which state of matter, solid, liquid or gas has the greatest thermal expansion and which has the least. Greatest thermal expansion, gas will be having the greatest thermal expansion because there are no intermolecular forces and this thermal energy can overcome the intermolecular forces easily. Thermal energy can overcome intermolecular forces. No need to write the what is this reason, but just gases. Which one has the least one? Solid will have the least one because thermal energy cannot overcome the strong intermolecular forces. Describe in terms of motion and arrangement of particles the structure of solids and gases. In solids, what is happening? Particles are closer to each other. Particles are close together in a regular arrangement. Then they will just vibrate. They just vibrate. Whereas in gases, what will happen? Particles are far apart. Particles are far apart and able to move quickly. They can be moving quickly and randomly. Describe specific heat capacity, the energy required per unit mass per unit temperature. The energy required to raise the what is this temperature or energy required per unit mass per unit temperature. This is 2 marks question, so you should be using it out compulsorily. 1 mark for unit mass and 1 mark for unit temperature. A student carries out an experiment to determine the specific heat capacity of a metal A and is heated by 12-watt electric heater. State the readings that he has to take it out. We know that formula for E equals to mc delta theta. So, and again, E is nothing but what? Power times time. Power times time. So what are the readings that he should be using it out? He should be using it out for power. Power is already there, so he should use time. He should be using mass, and this is already given. Then delta theta, he should be finding it out change in temperature. These all three readings are to be there because other readings are already given in the question. Question number 10. The figure shows a circuit with a 3-position switch. The moving part of the switch is always connected to Y and is around which it pivots. The other end of the moving part is labeled X, can be connected to point A, B or C. The resistance of the motor is 2 ohms and the resistor of the resistor is 3 ohms. Determine the current in the motor when the switch is connected to part A. If I'm connecting to part A, we can see that the circuit is open, so no current flows, 0 amperes. Now 0 amperes. Next time I will be trying to connecting it to B. Then if I connect it to B, only this 2 ohms is been coming into picture. So we know that I equals to V upon R, so which is 12 upon 2, which is 6 amperes. And finally, if at all I'm connecting it to C, then 3 ohms and 2 ohms both are being connected, which are in parallel. 3 plus 2, which is going to be 5 ohms. So the current will be now I equals to 12 upon 5, which is 2.4 amperes. Two resistors of resistance 2 ohms and 3 ohms are connected in parallel. Calculate the combined resistance. So combined resistance will be R1 R2 divided by R1 plus R2. So 2 times 3 divided by 2 plus 3, which is going to be 1.2 ohms. Next question number 11. Figure 11.1 shows the paths of alpha particles moving towards a gold foil. The four gold nuclei are shown. The paths of alpha particles. On figure 11.1, complete the parts of these alpha particles. We know that alpha particles are positive, 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 positive. Gold foil is also positive, 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 and positive. Now the first one, when it is coming, it's directly hitting, so it goes backwards because positive positive will repel and it goes backwards. The other one is not directly head-on collision, so it may go deflect and go it away. And the third one, it is going in between, so there will be no deflection and it goes in this direction. State the sign of the alpha particles. Just now we know that it is positive. Now the nuclear notation of the nucleus of gold is 198 Au 79. So this 79 indicates number of protons and number of electrons. This 198 equals to nothing but what? Protons plus neutrons. So 198 equals to 79 plus neutrons. This will give me neutrons as 119. Now coming to the last question. Figure 9.1 shows a direct current electric motor. The coil rotates about the axis when there is a current in the coil. The coil is connected to the rest of the circuit by the brushes. On the figure 9.1, draw the arrows to show which way the coil rotates. Explain the direction of the motion. So we know that we will be using it at Fleming's left hand rule. We will be using it at Fleming's left hand rule, where thumb shows the thrust or motion. Then the forefinger shows the direction of the field, and middle finger shows the direction of the current. Fleming's left hand rule. Now we can see that the always the magnetic field will be from north pole to the south pole, and the current is flowing in the direction of from positive to negative in this direction. We can see that current is flowing in this direction and comes over here. So once I take the first half part of the now I take the first half of the what is this or left half of the total motor. So in that way, what we can see that what we can see over here, field is going from the field is going from left to right, and the current is going upwards. Current is going upwards. So therefore, the motion using the Fleming's left hand rule, it will be going it out downwards. So the motion will be downwards over here. Now, when I compare to the next half of the second half of this one, the field is still going from left to right, but the current is going downwards. Current is going downwards. By using the Fleming's left hand rule, we can see that the motion is upwards. So the motion is upwards. So therefore, now from this side it is downwards and this side is upwards, means it is going in the anti-clockwise direction. So what am I going to write it out? On figure, draw the pair of arrows to show which way the coil rotates. So don't forget to draw the pair of arrows over here in this way. So travels from positive to negative of circuit. So force on left side is downwards, and on right side it is upwards. On figure 9.1, draw an arrow to show the direction of the electron flows. Electrons will be always flowing in the opposite direction. So therefore, the electron flows, we will be drawing it out in this direction. So what is the reason for that one? Why the electrons flow in that direction? Because electrons always flow in opposite direction. Electrons flow opposite direction of current. Opposite direction of current because electrons are negative and repel from negative connection of the supply. Then part B, state any difference in each of the following changes makes to the rotation of the coil in figure point 1 when the changes of the polarity. So now always we know that it goes from positive to negative. So therefore when the change in the direction is there, so the rotation also will be in the opposite direction, will be in opposite direction. Now change of the coil to the new coil. So original coil is only one loop, whereas over here two loops. So when there are two loops, more forces will be there. So therefore the coil will be turning faster because there will be more current. And using a stronger magnetic field. Stronger magnetic field also will make the coil turn faster. That's going to be the answer. So this is a predicted paper or a practice paper for paper 2 for physics. We'll continue in the next paper. Bye.